Welcome back again to solving numerical problems on engineering mechanics by Professor Timosenko, one of the most popular famous books in the world. Problem set 2.7 from friction part, solution to 2.108. You can expect such kind of problems if you are a aspirant looking for your JEE Advanced. So let me read out the statement. Two blocks. Here is a block A, here is a block B. Block B is on an inclined plane. Block A is in a horizontal plane. And both the planes are not smooth. There is friction. So two blocks are connected by a horizontal link, as you can look from the diagram, from A to B. This rod is a horizontal link connecting A and B. Are supported on two rough planes as shown in figure G. The coefficient of friction for block A on the horizontal plane here between block A and this surface, the coefficient of friction is given as mu as 0.4, and for the inclined plane, when the block B is trying to slide down, instead of giving the coefficient of friction directly, it is given the angle of friction for block A on the inclined plane, phi is equal to 15 degree. What is the smallest weight W of block A for which the equilibrium of the system can exist? So let me explain. There are two blocks, and the block at B, it tries to slide down because a component of its weight. As you know, if there is an object on an inclined plane like this, given this angle is theta, its weight is vertically downward mg. So to this side will be your mg times sine theta. This is a force. Mg sine theta is therefore a force. So when a block is kept on an inclined plane, it tries to slide down because of mg sine theta, provided this angle is theta. Now, if this angle is theta, then this component will be mg cos theta. So one of its component tries to make it slide down the inclined plane. So the block B tries to slide down the inclined plane. So the block A is pushed horizontally to the left. When this is trying to slide down, the block A is pushed to the left because both are connected by a link AB. So I have redrawn the diagram for you for better understanding, and the different forces are shown in red color. The same diagram is redrawn here. So this angle is 30. This is given for the block B. The weight is acting vertically downward is given as 1780 Newton. Therefore, this angle is 90. So in this triangle, this will be 30 because the sum of the three angles in a plane triangle, not a spherical triangle. A plane triangle is 180. Now, this is given as 60. Now, since this block B is trying to slide down, it is tending to move to this way. So the force of friction F2 is to this side. That will be mu2 times the normal reaction, where mu2 is the coefficient of friction between the block B and on this inclined plane. And when block A is pushed to this side, towards the left, between the surface of contact, between this surface and the lower part of the block A, the force of friction, let it be F1, will be mu times the normal reaction here. And the action force is W, so the reaction force is, let it be R1. So F1 will be mu1 times R1. And in this link, the connecting rod, connecting the block A and the block B, there will be a compressive force for block A will be to this side, and for the block B will be to this side. Now, so all the forces are now shown here. Here the reaction force R2, normal reaction. because this is the surface, so the reaction will be normal to that, R2. And why R2 will arise? Because a component of this 1780 Newton will be pushing this inclined plane to this side, called reaction force. So due to that, there will be reaction force R2 exactly opposite to that. Now, so once that is clear to you, now let us consider the point B and resolve the different forces along x-axis and y-axis. Let us consider this as x-axis and this as y-axis, which I have redrawn it here, which I have redrawn in a different diagram. So this is your x-axis, that is same thing as this is your y-axis, right? So F2 is along positive x-axis, the force of friction between the block B and the inclined plane, and weight 1780 Newton acting vertically downward. This angle I explained how this is 60, because this is 90, 60, 30. This is x-axis, this is y-axis. So this has to be 60. This is vertical, this is horizontal, so this will be also 30. Now, so let us apply sigma y is equal to 0. F2 is completely along x-axis, so this will not have a y component. Now, your R2 is along positive y-axis, so that is to be balanced by some forces along negative y-axis. So if you from here, from the tip of this force, if you drop a perpendicular from here to here, will be 1780 times cos 60, and from here if you drop a perpendicular on negative y-axis from this point to this point, that is the component of S along negative y-axis, so that will be S cos 30. So R2 is opposed by two forces, that is 1780 cos 60 and S cos 30. These two are in the negative y-axis, this is along positive y-axis. So for equilibrium, I make them equal. Now then apply sigma x is equal to 0. F2, that is mu 2 times the normal reaction R2 is along positive x-axis. So that is to be balanced by some forces along negative x-axis. So the component of 1780, if you drop a perpendicular here from this point to this point, this component will be 1780 times sine 60. And if you drop a perpendicular here, this one will be S times sine 30. So S times sine 30 and F2, they are along positive x-axis, and that is balanced by this component of 1780, that is 1780 times sine 60. So that is what I have written in equation 2, taking sigma x is equal to 0. Mu 2 times R2 plus S sine 30, because they are in positive x-axis, balanced by 1780 sine 60 along negative x-axis. You take this term to the right hand sides and mu 2 to the right hand side, so you are left with R2 is equal to 1780 sine 60 A minus S sine 30 over mu 2, your second equation. Here is R2 and here is R2. So let us make them equal in the next phase and solve and find out the value of S. Now the question is, how much is mu 2 here? Mu 2 is not known directly, but it is given. Mu 2 is not known directly. It is given for the block B, the angle of friction phi is 15. And in your school days, you must have learned the angle of friction or the angle of sliding. A tangent of that is nothing but the coefficient of friction. Since phi is given in the question as 15 degrees, so tan of 15 will give you the coefficient of friction mu 2 between the block B and the inclined plane. That comes out to be, if you put it in a scientific calculator, 0.2679. Now make make the right hand sides of equation 1 and 2 are equal, because the left hand sides, because the left hand side of 1 is R2 and the left hand side of 2 equation 2 is also R2, so the right hand sides must be equal. So I have made them equal. So I have made the two right hand sides of make them equal. Make a small correction here. This is not 30, 60. This is not 30, this is 60. So what do you do is, if you cross multiply, if you cross multiply mu2 is taken to the right hand side, so is multiplied with here, and mu2 is multiplied with this also. Now you have to make some side changes. Bring this term to the right hand side, keep it with this term, so that you can take s common. Then bring this term to the left hand side. So by taking s common, we are left with mu2 cos 30 plus sin 30 is equal to 1780 sin 60 minus mu2 times 1780 times cos 60. This is not 30, this is 60. This is not 30, this is 60. So now this term is multiplied here on the left hand side with s. If you take it to the right hand side, it is divided. Now put all these values in a scientific calculator. I have taken them individually. I have calculated the value of the numerator, putting in a scientific calculator, and the value of the denominator in a scientific calculator. If you divide, you get 1780.18 Newton is your value of s. Now since s is calculated, you can go back to equation 1 or equation 2. You can go back to equation 1 or equation 2 and put the value of s here to find out R2. You can do it so here also. So now put the value of s in equation 1 to get R2. So your R2 is equal to 1780 cos 60 plus s times cos 30. Now put the value of s here, cos 30, cos 60, 1780. This comes out to be 2431.681 Newton. Once that is done, we are only left with few minutes to finish the problem. Now come back to the original diagram. Let us apply the conditions of equilibrium for the object at A. W is to be balanced by R1, and to this side the force of friction F1, which is mu1 times R1, is to be balanced by the compressive force S, which we have already found out. So for equilibrium of this body, R1 is balanced by W and S is balanced by F1. So that's all. Now for the block A, for equilibrium, F1 is S, mu1 times R1 is your S, because force of friction is this. Now the equation 2, that is along y-axis, R1 is W. Now put this W here, so you get mu1 times W is equal to S. So your W is equal to S over mu1, and since mu1 is given and S we have calculated, just divide, you get W is equal to 4450.45 Newton. Thank you for watching. So if you really like and my work is worthwhile for you, you can give you feel free to write your comments, and if you like, you can pass on to your friends and subscribe the channel if you like. Thank you.